And for the transient period, so we want an expression little I at time t. We're going to use Laplace transforms. So we need to express, first of all, so how would that be expressed in S domain? So that is the fraction to get 6 is plus x. Then what do we do? As soon as we denominator like that, and that is split it into partial fractions. Yeah. It's equivalent to I over S plus V over 2000 plus S. Then next thing, those partial fractions, return the common denominator, yeah. So we've got to multiply A by 2000 plus S, and B by S. We can put that all back over. So now we've done that, what can we do? Break the numerators, yeah. So what are we going to do in terms of that? Equals 0. So 6000 is equal to 2000A. Therefore, A equals 3. Next bit, we let B equals minus. Yeah. So now we can put this up equal to back into this version of the so we 6000 3 over S all happy with that or not? And then we've got two parts to it, like entries in the table. This looks like A over S, looks like A over S plus B, no matter which order. So this bit becomes, transfers back to 3, and this bit transfers back to 3 to the minus 1000t. Finally, we can say, so that's I t, and then we can take the common 3 outside a pair of brackets. And we've got what we'll from that circuit, and that is an exponential rise to a limit. Questions about that? Move on. Look, a parallel and a part. I'll go at one of each, and I'll give you one to do as well. Volt step. 10 ohms. Henrys. 20 ohms. Okay, once steady state is reached. What you guess? You aren't getting where you get it from, Lewis? Okay. Okay, any other ideas? Let's switch on. Any ideas for what the current is? Close the switch. Think 1 amp, so think all the way through the transient bit. Wait. 1 amp at the time I turn on, as opposed to Lewis's 1 amp when we reach steady state. There's nothing wrong with that. I'm just contrasting the two ideas, that's all. Alright? It's worthwhile thinking about what you're going to expect to get. That's all the matter I'm trying to point out. So we've got one idea that thinks there's an amp when it reaches steady state. Another idea that the starting current and moment of switch on is an amp. Any other ideas? Think about what the inductor is once there's a steady state DC current. But yeah, and what about it? It's been given, it's got, as it stands, no resistance or negligible resistance. So now think about the steady state. Where do you get a third from, Lewis? Right, well, some ideas. We'll leave it there. Yeah. This is a piece of wire of negligible, or as it's drawn there, no resistance. Short circuit, the ohm resistor. Effectively, no current through there. Short circuit there. Only 10 volts across there. So you're right in what happens at steady state. So that's what we should expect to get from our analysis. Yeah. What about when I switch? I'm putting 10 volts across 10 ohms at for a minute. That's going to do something, right? But 10 volts across 30 ohms, is that not 2/3 of an amp? Right at that instant we switch on. See what we get, shall we? Do analysis. Alright? So, Vs is K/S. Write me an initial expression for Zs. I've got to include this. 10 plus, we got to do product over sum with them, haven't we? Yeah. So we got to do, that's the inductor. Yeah. Times 20 over 10s plus 20. And then we can 10 plus 200s over 20 plus 10s. And then that's probably a good idea here to get S on its own on the bottom here. How do we do that? Divide by 10. Now, here, it's a good idea to give both of these, make this have a denominator the same as that, so turn it into a fraction. So we go not too much like a 5 for my liking. That will allow us to write that over one common denominator and join these top bits together. So we got 10 brackets 2 plus s plus 20s. I'll write that in here. We have multiplied by 2 plus s over 2 plus s, i.e. we've multiplied that side by 1, so we haven't changed it. Yeah, what we've done there. Got the common denominator. Multiply brackets. So that top line becomes 20s plus, sorry, 20. 10 times 2 is 20, plus 10s, plus 20s, excuse me, all over 2 plus s. Finally, we can bring these two multiples of s together and say that z s is equal to 20 plus 30s over 2 plus s. Which is a bit of pulling around, but nevertheless nothing too difficult. Now we can bring into play the expression for I. So we can say IS is equal to VS over ZS. That is take another S over all this. I'm going to call this tidy fractions. And multiply them out to make them tidy. So we've got to go equals 10 over s times 2 plus s over 20 plus 30s. Then brackets 2 plus s all over s 20 plus 30s. You all still following me? Yeah. How can we write that? Well, what do we know? As soon as we see this down the bottom, what can we do? Yeah. Agreed? No dissenting voices. Now what can we do? Get equate numerators. So we can say let s equal 0. So 10 times 2 plus 0 equals I times 20. Therefore, I equals 1. Yep, agreed. Yeah, that's there. Look, 10 times 2 plus s, which is 0. So you've got 20 is equal to a times 22. A must equal 1. Yeah? Thumbs up? Good. So, what we got to let s equal for this bit to be nothing? If you can't see it, say this. Let a 20 plus 30s equals 0 and go through and work it out. That's 20a plus 30s equals 0. A equals minus 30s. S is equal to, hang on, we don't want the A in there, so I need the, sorry, that's my fault. That equals 0, so we don't need the A's. S is equal to 20 plus minus 30, which is minus 2/3. Yep, so if you can't see it, let that whole part of the expression, the brackets there, equal 0, and then rearrange S. Alright? Therefore, 10 times 2 minus 2/3 equals thirds. What does B equal? This bit is 40/3. Is it not? Ten times 2 is 20. What? How do you get it? Don't tell me. How do you get b is minus 20? Yeah. b is equal to 40 over 3 divided by minus 2/3, which is 40 over 3 times minus 3 over 2. Turn that bottom fraction upside down like we've been doing. Yeah. Minus 3 times 40. Over 6 equals minus 20. Yeah. Just want to know how you got there. That was okay. Everybody happy with that? We can now put those back in to our partial fractions. Yeah. So we can say IS is equal to I, which was 3, was it not? Minus 20. What? 1. Thinking of another problem I was doing, the one I'm going to use, I reckon. Minus 20 over what we got to do, that looks like something in the table. What we got to do this to make it look like something in the table. Sorry? Get rid of the 30. So how are we going to do that? Agreed? Yeah. Therefore, this now looks like A over S, and this looks like A over S plus B. So that transfers back to an I of T is equal to one for that bit minus 2/3 e to the minus 2/3 t. Note the two numbers, the two coefficients this time different, so we haven't got a bracketed term. Yeah. But we have got a 1 and a 2/3, and if we look at a graph of that function, we'll see down at 0.3 something there somewhere, and this point is 2/3 being taken we end up with we start with a third of the current that we got at steady state, and at steady state okay. So the inductor, what's happening in the circuit is at switch on, the change in current is causing a big back voltage in that inductor that's restricting the current forward. Becomes a short circuit, and we're left with 10 volts. Go. If I can find it. There we go. So a 40 millihenry inductor in parallel with a 5 ohm resistor, and that combination in series with a 15 ohm resistor.